Imagine for a moment a mission that could forever change how we see ourselves in the vastness of the universe. Right now, as you listen, there is an endeavor underway, one that grapples with obstacles that seem insurmountable, yet holds the promise of answers to humanity's oldest and boldest question. Are we truly alone? Journey with us as we explore a saga where science meets the edge of possibility and the future of our species hangs in the balance. Welcome to the Mars Sample Return Campaign, MSR. This is not just another NASA project. It is the highest priority in robotic planetary science, a title it has earned through decades of rigorous scientific review. In partnership with the European Space Agency, MSR seeks to bring back to Earth pristine samples of Martian rock, soil, and atmosphere. Precious fragments that could resolve the mysteries of ancient life and planetary evolution on the Red Planet. The Perseverance rover, braving the rugged terrain of Jezero Crater, has already collected dozens of samples, but this is only the beginning of an epic struggle. The stakes are immense, and so are the challenges. The original budget for MSR, a staggering $11 billion, has now been deemed unworkable. The anticipated timeline stretched out to the year 2040, a date that feels distant, expensive, and fraught with risk. Faced with spiraling costs and mounting delays, NASA has been forced to hit pause, re-evaluating every aspect of the mission. This is not just a financial dilemma, it's a race against time and the harshest technological limits humanity has ever confronted. Will there be a way out? Despite these towering obstacles, MSR remains the unshakable top priority, reaffirmed time and again by the decadal surveys of planetary science. Why? Because this mission holds the key to unlocking some of the deepest secrets of the cosmos. At its core, MSR is about answering questions that go to the heart of our existence. Did Mars ever harbor life? The Perseverance rover can only scratch the surface. Its instruments, while advanced, are dwarfed by the capabilities of Earth's laboratories. Only here, with our most sophisticated microscopes and detection methods, can we hope to spot the faintest traces of ancient biology, subtle chemical fingerprints that could prove life once flourished on another world. But the mission's significance doesn't end with the search for life. By analyzing Martian igneous rocks, scientists can reconstruct the thermal and chemical history of Mars, shedding light on how its mantle and core evolved. Isotopic anomalies in these samples will reveal the existence of primordial reservoirs in the early solar system, giving us glimpses into the birth and transformation of planets. And by examining the Martian atmosphere, we'll gain vital clues about how planetary atmospheres form and change, insights that resonate across the study of every world in our solar system. Yet the Mars sample return is more than a quest for scientific truth. It is the most crucial stepping stone for preparing humanity's future on Mars. To send humans safely, we must know how to build life support systems, devise strategies for using Martian resources, and develop planetary protection protocols to shield both Earth and Mars from contamination. The data we gain, ground truth, from authentic Martian material will calibrate every assumption, every plan, every dream we have for exploring the Red Planet. So, how will this audacious mission unfold? MSR is an engineering symphony composed of three intricate movements. First, there's sample collection. Perseverance, NASA's robotic pathfinder, has been meticulously drilling and sealing Martian rock and soil into 43 titanium tubes. As of now, 33 of these tubes are filled, each a scientific treasure awaiting return. Next comes the most complex chapter, sample retrieval. Originally slated for the mid-2020s, this phase involves landing a sample retrieval lander on Mars, launching the Mars Ascent Vehicle, the first rocket ever to lift off from another planet, and using a robotic sample transfer arm to load the cache. To reduce risk and increase flexibility, NASA has proposed an innovative backup: 2 mini helicopters, modeled after Ingenuity, capable of ferrying sample tubes to the lander if needed. Finally, the return journey. ESA's Earth Return Orbiter will execute a precision rendezvous in Mars orbit, capturing the sample container and transferring it to NASA's Capture, Containment and Return system. From there, the samples will be sealed for the long voyage home, re-entering Earth's atmosphere and landing safely, all while upholding the strictest planetary protection standards to prevent cross-contamination. And at every step, safety is paramount. Technologies have been developed to ensure that no Martian microbe, if it exists, will threaten our biosphere or that of Mars. It is a technological arms race for the safety of all life. But behind the scenes, the mission faces a financial and technological nightmare. MSR, one of the most elaborate undertakings in space exploration history, has seen its costs balloon, making the original $11 billion estimate a political albatross. Delays threaten to push the mission's completion to 2040, a timeline many see as unacceptable, a potential squandering of money, morale, and scientific opportunity. Imagine launching a rocket from another planet, catching a tiny container of samples in orbit, and safely returning them millions of miles to Earth. Each step is fraught with risk. Any failure could doom the mission and generations of work. Budget constraints have already forced painful cuts. Thousands of engineers and scientists now face uncertainty, their work hanging in the balance. Even the scientific community's highest priorities can crumble without steadfast financial and political backing. Yet, NASA refuses to yield. Confronted by crisis, the agency is rallying the entire space industry to propose the most creative, cost-effective designs. The new goal? Bring the samples home sooner, potentially within the 2030s, while slashing costs and minimizing risk. It is a clarion call to action, a last-ditch sprint to save the most critical mission in contemporary planetary science. And this is not just an American venture. MSR stands as a shining example of international cooperation. ESA's contributions from the Earth Return Orbiter to the Sample Transfer Arm are indispensable. This partnership transcends borders and politics, uniting nations in pursuit of a common cause: the advancement of human knowledge. So where do we stand today? Perseverance has already made history, filling 33 of its 43 sample tubes, a cache of data and discovery waiting to be unlocked. While the earliest return date may stretch to 2040, NASA has made it clear this is not acceptable. Every effort is being made to accelerate the timeline, to ensure that the race for Martian samples is won, not lost. MSR is more than a sample return mission. It is a strategic investment in humanity's future, a proving ground for new technologies, a pledge to safeguard both Earth and Mars, and the foundation for a permanent human presence on another world. Despite impossible odds, NASA and its partners remain resolute, because, as promised, these precious Martian samples could one day transform forms show us everything we know about our place in the cosmos. The future of Mars exploration is within reach. The only question is, are we ready for what those samples might reveal?